In our previous classes, we have read that a chemical change is a permanent change. It cannot be reversed. For example, curdling of milk and rusting of iron. Whenever chemical change occurs, the nature and identity of the initial substance or substances changes and a new substance or substances is formed. We can say that a chemical reaction has taken place. Now the question is how to know that a chemical reaction has taken place. The answer is at least one of these four will occur. Change in state, change in color, evolution of gas, or change in temperature. Let us see some examples. Lead nitrate is a colorless crystal or white powder. Its aqueous solution is clear and colorless. Potassium iodide is a white powder. Its aqueous solution is clear and colorless. Lead nitrate and potassium iodide react to form lead iodide, which is a yellow precipitate. In this chemical reaction, you see change in state as well as change in color. Zinc granules are silver gray in color. When they react with dilute hydrochloric acid, colorless zinc chloride is formed. In this chemical reaction, you see change in state, change in color, and evolution of a gas. If you touch the conical flask or test tube in which reaction is taking place, it will be warm. Magnesium ribbon, which is silver gray in color, burns with a dazzling white flame and changes into a white powder. This powder is called magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. In this chemical reaction, you see the change in color. Any chemical reaction can be written in three forms. First, in a sentence. Second, in a word equation, and third, in a chemical equation. Let us understand this with an example. When a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This is representation of a chemical reaction in a sentence. The word equation for the above reaction would be this one. Chemical equations can be made more concise and useful if we use chemical formula instead of words. For example, magnesium is represented by Mg, oxygen by O2, and magnesium oxide by MgO. Now let us talk about the structure of a chemical equation. These are called substances. Substances are elements or compounds that participate in a chemical reaction. The substances that undergo chemical change in the reaction are the reactants. The new substances formed during the reaction are called products. The reactants are written on the left hand side with a plus sign between them. Similarly, products are written on the right hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. If the number of atoms on the left hand side and right hand side of the arrow are same, equation is balanced. If not, then equation is unbalanced. An unbalanced chemical equation is also called a skeletal chemical equation for a reaction. Now let us talk about how to balance a chemical equation. As per the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Let us see if this chemical equation is balanced or not. There is one iron atom on the left hand side and 3 iron atoms on the right hand side. So iron atoms are not balanced. There are 2 hydrogen atoms on the left hand side and 2 hydrogen atoms on the right hand side. So hydrogen atoms are balanced. There is one oxygen atom on the left hand side and 4 oxygen atoms on the right hand side. So oxygen atoms are also not balanced. Overall, the chemical equation is not balanced. First important point to remember is we cannot alter the formula of the elements or compounds in the reactions. For example, Fe cannot be written as Fe2 or Fe3. H2O cannot be changed to HO2 or H2O2. Fe3O4 cannot be changed to Fe3O5, Fe2O3, etc. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. This unbalanced chemical equation has 4 substances. Out of these 4 substances, Fe3O4 has got maximum number of atoms. They are 7, 3 iron atoms and 4 oxygen atoms. Oxygen atoms are more than iron atoms, so we will start balancing oxygen atoms first. There is one oxygen atom on the left hand side and 4 oxygen atoms on the right hand side. So we will write 4H2O on the left hand side. So there will be 4 oxygen atoms on the left hand side and 4 on the right hand side. Now there are 8 hydrogen atoms on the left hand side, 4 into 2, and only 2 hydrogen atoms on the right hand side. So we will write 4H2 on the right hand side. So the hydrogen atoms on the right hand side will become 4 into 2 means 8 hydrogen atoms. So hydrogen atoms will be balanced. Next we will see iron atoms. There is only one iron atom on the left hand side and 3 iron atoms on the right hand side. So we will write as 3Fe on the left hand side to balance the iron atoms. Now every element, iron, hydrogen and oxygen, have same number of atoms on the left hand side as well as right hand side. So this is a balanced chemical equation. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient, as we have just seen. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. The gaseous state is represented by small g, liquid by small l, aqueous by AQ, and solid states by small s. The word aqueous AQ is written if the reactant or product is present as a solution in water. Let us see this example. Lead nitrate and potassium iodide react to form lead iodide, which is a yellow precipitate. Lead nitrate, potassium iodide and potassium nitrate, they are aqueous solutions. So we write AQ next to them. Lead iodide is solid, so we write S next to it. Down arrow is precipitate symbol. Let us see example 2. Zinc granules are silver grey in color. When they react with dilute hydrochloric acid, colorless zinc chloride is formed. So zinc is solid, so we write S next to it. Hydrochloric acid is aqueous, so we write AQ. Zinc chloride is aqueous, so we write AQ next to it. And hydrogen is gas, so we write G next to it. Upward arrow is the symbol of gas. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. Let us see these two examples. Carbon monoxide gas reacts with hydrogen gas at 340 atmospheric pressure to form methanol or methyl alcohol. 340 atm is written above the arrow. In the second example, aqueous carbon dioxide reacts with water in the presence of sunlight and chlorophyll to form glucose, aqueous oxygen and water.